Welcome to another episode of learning. I thank each one of you for watching my videos and encouraging me. Please like my videos and share them with your friends and colleagues. Please subscribe my channel if you have not already subscribed. Thank you. We continue the discussion of the solutions of the problems that have appeared in the JEE Main exam in the January 2025 session. In this video, we discuss the last three problems, the solutions of the last three problems from the section Matrices and Determinants. And this is the fifth part out of the 5 parts that is dedicated to matrices and determinants. Right, this is the question that has appeared in the JEE Main exam held on 23rd January 2025 in the first shift. If A, B and adjoint of A inverse plus adjoint of B inverse are non-singular matrices of the same order, then the inverse of A into the inverse of adjoint of A inverse plus adjoint of B inverse multiplied by B is equal to. We are given 4 options. So these are the 4 options given to us. Let's now discuss the solution of the problem in detail. We are given AB and adjoint of A inverse plus adjoint of B inverse are non-singular matrices of the same order. Right. Now we take A into the inverse of this matrix. Therefore, the inverse of this matrix is A into, in brackets, adjoint of A inverse plus adjoint of B inverse whole inverse into B, and for the whole of that, the inverse. Right. We now use the reversal law. What is the reversal law? The inverse of x, y, z is equal to z inverse multiplied by y inverse multiplied by x inverse in the reverse order. This is equal to B inverse, and the inverse of adjoint of A inverse plus adjoint of B inverse and its inverse into A inverse. Right. Now here the inverse of adjoint of A inverse plus adjoint of B inverse is without this inverse. The inverse is to be taken out. Why? We use the result x inverse is equal to x. So that is equal to B inverse adjoint of A inverse plus adjoint of B inverse. The inverse is not there, into A inverse. Now use the distributive laws. If you use the distributive laws, B inverse adjoint of A inverse into A inverse plus B inverse into adjoint of B inverse into A inverse. Right. Now see here, adjoint of A inverse multiplied by A inverse, and we have adjoint of x into x is the determinant of x into I, where x is A inverse. Right. And B inverse adjoint of B inverse is x into adjoint of x is determinant of x into I, where x is B inverse. So use this result. So this is equal to B inverse into inverse of A, the determinant of A inverse, right? The determinant of A inverse into I plus this is determinant of B inverse into I into A inverse. Right. Now for A inverse, we write the formula x inverse is equal to 1 by determinant of x into adjoint of x, and here determinant of A inverse is there, and that will be 1 by determinant of A. Determinant of X inverse is 1 by determinant of X. So for B inverse, we write adjoint of B by determinant of B into determinant of A inverse is 1 by determinant of A plus determinant of B inverse is 1 by determinant of B. For A inverse, the formula adjoint of A by determinant of A. And all are non-singular, no problems will come. Right? This is equal to determinant of A into determinant of B. Determinant of B into determinant of A is determinant of BA. Determinant of BA is same as determinant of AB. So this is 1 by determinant of A into determinant of B into, in brackets, adjoint of B plus adjoint of A. And that is, and 1 by determinant of A into determinant of B is 1 by determinant of AB. That is that. So the answer is appearing against option 4. Therefore, the answer to this question is option 4, and that is the detailed discussion of the solution of this problem. Right. We move to the next question. This question has appeared in the JEE Main exam held on 22nd January 2025 in the second shift. The given question is, if the system of linear equations x plus y plus 2z is equal to 6, 2x plus 3y plus az is equal to a plus 1, minus x minus 3y plus bz is equal to 2b, where a, b are real numbers, has infinitely many solutions, then 7a plus 3b is equal to. We are given 4 options. Right. This is a very regular routine question. So you are given a system of equations, and in which 2 unknowns are there, a, b are there, and it says it has infinitely many solutions. Then find the value of 7a plus 3b. Right. Let's now discuss the solution of the problem in detail. The system, this is the system 1 of equations, have infinitely many solutions. If delta is equal to delta 1 is equal to delta 2 is equal to delta 3 is equal to 0, where delta is the determinant of the coefficient matrix of the system, and delta 1 is, it is the determinant same as delta, whose first column is replaced by the values 6, a plus 1, 2b. Delta 2 is same as delta with the second column replaced by 6, a plus 1, 2b. Likewise delta 3. And to have infinitely many solutions, all these must be equal to 0. Let us take delta. Delta is equal to 0. And in this delta, I have made 2 1 element, a21 and a31 elements 0. To make that one, we have made a elementary row operation. So make this 0, R2 minus 2R1 I have done, and to make this 0, R3 plus R1 we did. So we got this matrix, and this is equal to 0, and expand by means of the first column, that will be 1 into b plus 2 into a minus 4 is equal to 0, and simplifying we get 2a plus b is equal to 6. This is the first equation, and let us take delta 3 is equal to 0. That will be convenient for me, because here I get the product terms. The product terms I will get, therefore I do not want that. So I have taken delta 3 is same as delta with this third column replaced by 6a plus 1 2b is equal to 0. And again I made this equation, this is 0, the same elementary operations will work here, and expanding by the first column we get 2b plus 6 plus 2 times a minus 11. Simplifying we will get 2a plus 2b is equal to 16. 2a plus 2b is equal to 16. 2a plus b is equal to 6. Subtracting we will get b is equal to 10. So solving with 1 and 2 equations, we will get b is 10, a is equal to minus 2. Now we want to evaluate 7a plus 3b. 7a plus 3b is equal to 7 minus 2s are minus 14 plus 3b, 3 10s are 30, and minus 14 plus 30 is 16. Where is the answer? Option 1. So the answer appears against option 1, and that is the detailed discussion of this solution. Now one may question, sir, you have not tested delta 1. Is delta 1 0? Delta 2 is 0? To test delta 1 is equal to 0 and delta 2 is equal to 0, take delta 1, substitute the value a is equal to minus 2, b is equal to 10 in this. Then will be a plus 1 will be minus 2 plus 1 minus 1, and a is minus 2, 2b is 20, b is 10. Substitute. Likewise in delta 2 also you do it and evaluate the determinants, and you will find the determinants are 0. So take a is equal to minus 2, b is equal to 10 in delta 1 and delta 2. We find on evaluation, we will get delta 1 is equal to 0, delta 2 is equal to 0. Right. So that is the detailed discussion of this example, and it is a very regular routine question. We continue in the next slide. Right, this is the question that has appeared in the JEE Main exam held on 22nd January 2025 in the second shift. The given question is, for a 3 by 3 matrix M, let trace M denotes the sum of the diagonal elements of M. Trace M denotes trace of the matrix M, which is nothing but the sum of the diagonal elements of M. Let A be a 3 by 3 matrix such that determinant of A is 1 by 2 and its trace is 3. If B is adjoint of 2A, then the value of determinant of B plus trace of B equals. We are given 4 options. Let's now discuss the solution of the problem in detail. We are given a 3 by 3 matrix. We are given determinant of that matrix is 1 by 2 and trace of A is 3. And we are given B is equal to adjoint of 2A, and we have to find its determinant and we have to find its trace and add, and what is the answer? Right. B is equal to adjoint of 2A. And now recall, if A is a square matrix of order n, then adjoint of A is determinant of A to the power of n minus 2 into the matrix A when A is non-singular. Now here that you apply here, this is equal to determinant of, in the place of A we have 2A, determinant of 2A to the power of n minus 2, that is 3 minus 2 into A, that is 2A. And this is a determinant of 2A into 2A multiplied by 2A. And now you apply determinant of the k scalar times A is equal to k power n determinant of A, where n is the order of that square matrix A. And this will be, A is a 3 by 3 matrix, therefore we will get determinant of 2A is equal to 2 cube into determinant of A multiplied by the matrix 2A. Now, and the determinant of A is 1 by 2 is given to us. So 2 cube into 1 by 2 into 2A, simplify, you will get 8A. So B is 8A. So when B is 8A, determinant of B is determinant of 8A, and determinant of Ka is equal to k power n determinant of A, where n is the order of the square matrix A. So determinant of 8A is 8 cube, because A is a 3 by 3 matrix multiplied by determinant of A. And 8 cube into determinant of A is 1 by 2, and this will be 256. Right. Now trace of B, that is trace of 8A. Now recall, trace of K times A is K times trace of A. So the trace of 8A is equal to 8 times trace of A. That is 8 into trace of A is given to be 3. So 8 3s are 24. Now we want determinant of B plus trace of B, that is 256 plus 24, that is equal to 280. Where is 280? Option 2. Therefore, the answer to this question is option 2, and that is the detailed discussion of the solution of this problem. And in this video, the last 3 questions from the section Matrices and Determinants have been done, and this is the 5th part of the 5 parts of the video on Matrices and Determinants, and this is the end of the section Matrices and Determinants. I am sure that you have understood the solutions of these 3 problems. I thank you for watching this video now. I thank each one of you for watching my videos and encouraging me. Please like my videos and share them with your friends and colleagues. Please subscribe my channel if you have not already subscribed. Yes, I am sure that we are going to meet you all in another episode of learning. Enjoy learning mathematics. I wish you all the best. Thank you.